solving log equations. Everything that we've been working on up until this point has been kind of like the precursor of being able to solve these equations. We are going to be using all the properties of the logs that we've had so far to be able to solve for x. A lot of times our value of x is going to be in an exponent. And remember, logarithms are nothing more than exponents written weirdly. So what I want to do here is kind of give you guys a couple of quick examples, and we'll just build off of this more tomorrow. All right? I wanted to use today to kind of reiterate the log fort rules from yesterday, expanding and condensing, and then get into a little bit of this today. So let me show you an example. In order to solve simplistic log equations, one of the rules that we're going to do, I'm not going to worry about this, is that I want to be able to get a common base. Okay? If you look at a problem like this, notice where our variables are. Where are they? They're up in the exponents. And if
Wait,
they're
is
up
that a
in,
1 exponent, or is it just like...
yeah, it's 4 to the 3x and 8 to the x plus 1. That x plus 1 is the whole exponent. So what I want to be able to do in order to solve for x here is that I have to get those common bases. And remember, one of the rules that we had in the past about logarithms is that if we had a log of a base to a base of x, when those two bases were the same, what happened to that exponent? It dropped down. So what I'm going to do here is try to get some common base between a 4 and an 8. How can I rewrite 4 with a common base of an 8? Bless you. 2. You agree? So here's what I'm, and you're right, I heard you say it. On the one on the left, I can say that this is 2 to the 2 times 3x. Because 4 is 2 squared, right? On the other side, could I say it's 2 to the 3 times the x plus 1? All I'm doing is rewriting the 4 and the 8 as a common base.
Oh my god.
Now, what? All right. Here's where the rule is that I'm going to do. I'm going to log both sides. By logging both sides with a common base, remember when we're dealing with equations, if I log both sides, I keep the equation balanced, correct? What happens to the exponents? They drop. And you get 6x equals 3x plus 3.
So
What's x? 1. No. What did I do for the base?
Oh, the base is 2.
Exactly. Exactly. I'm using those properties that we've done before to get the exponents, I don't know, out of thin air, if you want to call it that. No. Exactly. That's exactly. So the first couple that I do, I'm going to kind of put in what we're actually doing. But I want you guys to see, once you get that common base, done. Yes, sir.
Then how can you just like add a log base to multiply both sides?
How do you just multiply both sides by 2? You just do it. Because you can. She's not taking any guff today. Look at those shoes. She's out there. She's going to shave her head tomorrow and have a tattoo on it. And a wallet with a chain. That is a punk reference. But again, whenever we solve equations in the past, whatever you do to one side, if you do it to the other, isn't it still the same equation? That's all we're doing. Okay? Let's go a little fancier. Let's try this one. Again, what I want to be able to do here is rewrite both those bases. Guys, I want to get these guys to have that common base. I want to have that same value on both sides so that way I can log either side and get the exponents to fall. What are you going to change the bases to? 3's. So on the left-hand side, what do you get when you change that base to a 3? What's your new exponent? 4x. I'm just going to write it just like this so that we understand what we're getting at here. Everybody okay with that? On the other side, I have 3 to the x minus 6. Now, what I'm doing here, guys, is I'm logging both sides with a base of 3. Do you, and like Bailey just asked this, do I have to say that I'm taking the log of both sides? I really don't. But remember, what you really are doing is you're taking the log of both sides, and by doing that, these drop through, and you get 4x is x minus 6.
And x equals -3. I'm negative 2.
Right. Will you show us a really complicated one?
Maybe. All right. Now, with our calculators, could we check our answers to make sure it's correct? I bet you're right. Now, if I just checked in my calculator and went and said 9 to the 2 times -2, that's 9 to the -4, right? That'll give me some nasty looking number. If I check that to see is that going to equal 3 to the -2 minus 6, all you have to do is just substitute in your calculator and see what you get. If it's equal, yay, you did it right. If it's not, boo, there's no solution. All right? It's really all it is.
Wait, there's no solution, or you did it wrong?
Maybe. Probably. Now let's make it weird.
They did like
I don't like this. It's difficult.
This is where this is about as weird as it gets, and this is the one step that we did not get towards yesterday, and I felt that there's really no need for us to discuss it. Excuse me. To discuss it yesterday because we're only going to use it for this section. How am I going to get that x out of the thin air? I have to take the log of what? 2. So in order to get that x to fall out, I have to take the log base 2 of the 2x, and it has to equal the log base 2 of 7.
And then x equals log base 2 of 7.
X is going to equal log base 2 of 7, but what does that equal?
A number.
A number, all right?
an irrational number.
Here's what happens. Your calculators are set up in such a way that it's all base 10. In order to get a value for this to work, we're going to use what's called change of base. Change of base to get this to work is nothing more than this. X is going to equal the log of 7 divided by the log of 2. Take the number, the log of the number, divided by the log of the base. No. Because if you think about it, the log, you're looking at something, what you're asking here, log base 10 of something, remember, let me write this out.
Couldn't you just use the log on the calculator that actually lets you choose the base? It's under math.
We're doing the same idea here.
Well,
I'm showing you what that actually means. It's 2 point something, I think? Sure. All right. What you're doing here is you're setting up what's called change of base. It's whatever the number is in the numerator divided by the log of the base. Now, most of you guys probably already found that button on the calculator because there is one. Tangent. Just wait. We'll get there. It's going to be
so
awesome.
we're gonna go on a tangent.
Math, number, where is it?
Alpha A. Just do alpha A.
Is that where it is?
No, do math. Just start math and then do alpha A.
Do alpha window.
Alpha math.
Alpha
Alpha
window.
math.
If you
Then
put
go down
alpha
to log base.
There it is.
Alpha.
Log base number 5.
Ah,
It'll do it there too. If that takes too many buttons, just remember it's the log of whatever it is divided by the log of the base. It's just that easy. And sometimes that's quicker.
So they have 2 buttons
Alright.
for log.
Again, if I'm looking at 5 to the x, what logarithm base would I have to take on both sides to make that work? Log base 5. So x is going to equal the log base 5 of 8, otherwise known as log of 8 divided by log of 5. You're going to get the same answer. To be honest with you, I know that you can do the change of base in the calculator. It has the buttons to adjust the bases for you. I think it's just quick. It's sometimes a little bit easier just to type it in. I'm trying to remember though on these calculators. When you hit log, does it open up a parenthesis?
Yes.
You just have to remember to close that parenthesis when you divide it. That's all.
You can't close the, oh, yeah, you can.
So I hit log of 8, close the parenthesis, divided by the log of 5.
Click alpha, and then click alpha.
1.29. Again, not so scary.
Well, we're gonna get scary, aren't we?
Eventually.
Get scary, get scary.
Let's try this one. Take another step of it. Now we have a multi-step problem. Once we get into the multi-step stuff.
At least I have lunch after this, and I can go eat lots of cookies.
Now, in this case here, what do you have to do first, guys?
Minus 4.
Subtract 4. Good. Subtract 4 from both sides, so you have the 10. 2x minus 3 equals, what is that, 17? How do I get that exponent to fall? Log. So, in this case here, if I take the log of both sides, do I have to worry about it being changing the writing down the base here? Can I just write log? All right. If I say it's the log of this equals the log of that, I get 2x minus 3 is log of 17.
So wouldn't you just add 3 and then divide it all by 2?
Exactly what you do. Because, ladies and gentlemen, log of 17 is just some crummy looking decimal. Just like when you guys used tangents and sines and cosines last year. Remember how you got those crummy looking decimals, but you still were able to solve equations with them? It's the same process, guys. If you type in your calculator now, x is going to equal the log of 17, close that parenthesis, add 3, hit enter, divide it by 2. It's a multi-step problem that you're just using your calculator for. Because with log of base 10 is just plain log. Okay. Yes, sir. No, you can't, because you're taking the log of that. That's what you're taking the log of. So that's why you just have to remember when you type in your calculator, throw parentheses around it. Let me give you guys a couple of these to try. We'll build off of this a little bit more tomorrow. It shouldn't be that bad.
No more kids.
This is section 8.6.
I actually read that part though. It takes a long time.
Or what we could do is go through the homework. We have it then.
Yeah, just in case.
I'm gonna, because I'll probably read over it.
I can't remember some flex. All my friends are flex.
Let's try those. Just give you a few of them to start with. I'm going to throw a couple of E in there and a couple in there. Just try to see what you can get at, all right? We'll build off this a little bit more tomorrow and try to make it a little more complex. Because there are a couple other styles of these problems we'll get at. Okay? Questions? Trust me, he's been in my class for the past year and a half. He's a very, very weird kid.
Dude, me and Mr. Murph, we tiny.
Mr. Murph and I.
Mr. Murph and I, remember that boating trip? Remember that, Mr. Murphy?
Oh yeah, the one that wanted to fit.